Coming up from mobile learning in the classroom, geometry apps from Horace International. Hi, my name is Trainin, and this is Mobile Learning in the Classroom from TechEdge, and today I want to talk about geometry apps from Horace International. I was clued into these apps by a friend of mine when I was visiting in Israel, and he showed me these apps, and I thought this was a spectacular learning opportunity in the area of geometry, especially Euclidean geometry. And I'm going to show you the first one. This is Pitagoras. And you can see that you can learn lots of topics. Some instruction before this would be useful, but what I love about this app is that in each area it leads you through a series of progressively harder problems that take some imagination to solve, and the fact that you actually have to use your practical knowledge and inquiry to solve this problem and to deeply understand these concepts and not just repeat or not just go through is really, really strong. It gives you some directions about how to play, and you can see that it shows you how to do different things. For example, get points on the board or get sizes and all of that. And the first thing is, please, and this is a simple task, construct a segment between those 2 points, and you're correct, and the next problem comes immediately. Now you need to find the midpoint. Now it gets more complicated, lots of ways to do that. I'm just going to cross the other diagonal and find out that this is the center. You see that it turns yellow, and that shows that it's right, and then I can move to the next problem. Now, again, the midpoint of the segment, this is a little bit more complicated because I couldn't just put my finger in there on it. Why? Because there is no intersection there. You've got to create an intersection before you can do that. So it walks you through each one of those problems. And now I need to construct 2 points that intersect. So I need to divide it essentially into 3 equal parts. And so I can take and make these 2 intersections, and I make these 2. It does not confine you to one way to get to the solution, but it will not tell you that you're right, even if you're partially right, until you've got all of it. Let's do 3 parts. So 1 and 2, 3 equal parts. And now it asks a different kind of question. So you can see that there's a variety of questions that they ask. So for example, let's take all the nodes at a distance 2. So it's this one, this one, this one, and this one. These are the nodes that are at a distance 2 from that point. So you can see how it's getting progressively complex. This is the node that is equidistant, and you can see that this leads. But if I take you somewhere else, for example, you can see how fast you advance, and there's actually a world leaderboard for people who have gone through all of this. You can see that there are lots of topics. So it starts with simple things and it builds up. Length and distance is at the beginning, parallel lines, isosceles triangles, medians, and you can see you get to trapezoids, Pythagorean theorem, area, right angles, rotations, angles, and tangents. So it gets progressively more complicated. It's really, really a fantastic way to learn and to practice these kind of skills. Now, this is not the only app they have. I can show you a few more apps. They've got Pitagoras 60 degrees, and this focuses on, and you can see that I've been playing with it, it focuses on the same thing, but now instead of squares, you have a grid that is a series of 60-degree angle triangles. So the calculation is different, and the ways you can maneuver around this is a little bit different, so it is more sophisticated. And you can see that the trick is exactly the same trick. You have, in this case, in parallel lines, you have to select 2 parallel lines, so you have to make the judgment about which lines are parallel. So this is another one where you can experiment, try things out. They also have a 3D version, so now we're past the general 2D Euclidean geometry to looking at different three-dimensional shapes and identifying different things. So for example, you can see that you can look at something as basic as cubes, and here you need to mark all the edges that intersect the given edge. So it would be something like this. and now I've got it correct, and you go to the next problem, you get the problem, complete the degrees given some of the edges, so you got to go and complete these. And you can see that the principle is the same, but obviously the learning is more complex, and there is a quick way to advance forward and backwards. You can't advance past your best result, but you can go back and redo older drills, and you can quickly go through. In this one, and I love this, it doesn't actually let you go to the next level without completing this one. And again, I've played with this quite extensively, not necessarily on my iPad, because, and this is important to know, and we talk about this a lot, it's important to have this, and this works wonderfully well on the iPad, but there's actually a version on Google Play, there's a version on Amazon apps, and there's a version that works on the phone. So you are not restricted to iPads only. Almost any platform you have will have these apps work and work well. So this is a fantastic way to practice geometry, and more than that, to do very sophisticated problem solving. The one thing that I would suggest to anybody using that with students or with kids, if you're a parent and you're using it with kids, or if kids choose to use it themselves, is to make sure that after you solve a problem, you give an account of how you solved it and why do you think it worked. Because I think that that metacognitive piece, and I keep going back to this, is the most important. Sometimes you solve intuitively, but you can't verbalize it, which means that you actually will have a hard time to transfer that learning to another domain. So thinking about how you got that result is especially important. So my name is Trainin. This is Mobile Learning in the Classroom, and I'll see you next time.